Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that the orders are randomly selected from those included in the table. Again, the title of the table is drive-through restaurant. We have column A, B, C, and D, which represents the restaurants, and then we have two rows where we have order accurate and an order that's not accurate. Now, if one order is selected, the first part of our question is we want to find the probability of getting an order from restaurant A or an order that is accurate. Now, are the events of selecting an order from restaurant A and selecting an accurate order disjoint events? So let's go ahead and open up our table here. And the first thing I want to do is let's find out what the totals are for the columns and the rows. So we're going to do that for each one. So what are the total order accurates and order not accurates for a restaurant A? So we're just going to go ahead and add those up. So 327 plus 32, which gives us 359. Okay, then we're going to take 278 plus 60, and that gives us 338. And 245 plus 30 gives us 275. 140 plus 19 gives us 159. And then let's add across. So 327 plus 278 plus 245 plus 140 gives us 990. And then let's go ahead and then add the next row, which is 32 plus 60 plus 30 plus 19, which gives us 141. So we can either add the totals in the rows or the totals in the columns to get our total amount. So if we take 990, add 141, and that gives us a total of 1,131. Okay, so to find the probability of A or B, we would add the number of ways event A can occur and the number of ways event B can occur, but add in such a way that every outcome is counted only once. The probability of event A or B is equal to that sum divided by the total number of outcomes in the sample space. Now, the formal addition rule is the probability of event A or B is equal to the probability of event A plus the probability of event B minus the probability of event A and B, where the probability of event A and B denotes the probability that A and B both occur at the same time as an outcome in a trial of a procedure. But in this case, we're just going to find the probability intuitively as opposed to using the formula here. So when selecting an order from a restaurant, we need to find out what is the total different orders from which to select. Well, if we come back up here, we found the total was 1,131. So n is going to equal 1,131. Okay, now we want to be able to count the number of orders which were from restaurant A, which is the first column, or were accurate, which is the first row, but be careful to count subjects exactly once. So we're going to begin by counting the number of orders that were accurate. So if we come up here and we take a look at the total row that we added up, we added the order accurate row and we got 990. So therefore there were 990 orders that were accurate. Now notice that there is an overlap between orders that are from restaurant A and orders that are accurate, and that these values have already been accounted for. However, restaurant A orders that are not accurate still need to be counted. So there were 32 orders in restaurant A that were not accurate. So let's take a look here and see what they're referring to. So what I want to do is we want to be able to find out what are all the values that we added in the order accurate. So we're starting here, and this is what we get when we add those all up. Okay, And then we also want to find out what are all the values from restaurant A. Well, from restaurant A, we know that we have these two values. Okay, now if we take a look at this number 327, we cannot add that twice. So if we add it with the row and the column, that means we're repeating a value that we cannot include. So we can only include this 327 once with this amount. So the only number that we need to add from column A is the number 32, since this is already accounted for. So again, there were 32 orders in restaurant A that were not accurate. So what we want to do is add the frequencies of orders that were accurate to the frequencies of orders from restaurant A that were not accurate, and then divide by the total number of orders to calculate the probability of getting an order that is accurate or from restaurant A, and then we're going to round that to 3 decimal places. So we have the probability of event A, which is equal to 990. Those are the numbers or the value here that we got from adding the rows for the order accurate. And then what we're going to do is we're going to add the 32, because again, we're not going to calculate this number twice, and that's from restaurant A. And then once we do that, we're going to divide it by the total number, which was 1,131. So now let's go ahead and add these. So when we add these together, we get 990 plus 32, which gives us 1,022. And then we're going to divide that by 1,131. And so we get the following number. We get 0.90362. And then we'll write 5. Okay, now again, they're asking us to round this to 3 decimal places, so we're going to round it to 3 decimal places. Now keep in mind that 3 is the rounding digit and 6 is a testing digit, so we're going to round up here, so we get 0.904, or approximately 90%. So let's go ahead and put that in here, 0.904. So we're going to say that the probability of getting an order from restaurant A or an order that is accurate is 0.904. And let's check our result. And there's our answer. Okay, now the next question says, are the events of selecting an order from restaurant A and selecting an accurate order disjoint events? Okay, now remember that we want to find out what does disjoint actually means. Now, events are disjoint if they never occur at the same time. So what we're going to want to say for this result is the following. We're going to say that the events are not disjoint because it is possible to receive an accurate order from restaurant A. So you would say that the events are not disjoint because it is possible to receive an accurate order from restaurant A.